Welcome to Docker Deep Dive, from containers to scalable microservices.
Hello, I'm excited to guide you through the world of Docker. We'll explore containers and images, the core building blocks of Docker. Imagine Docker as a shipping company, where containers are the shipping containers and images are the blueprints for those containers. By the end of this video, you'll grasp how these elements revolutionize software deployment, enabling consistency across different environments. We will unravel the mysteries behind Docker's architecture and show you how it simplifies the process of packaging, deploying, and scaling applications with ease and efficiency. Let's dive in and demystify Docker together. We'll start with the fundamental concepts. First, let's understand Docker images. Think of a Docker image as a read-only template, like a snapshot of your application and its dependencies. Includes everything needed to run the application: code, runtime, system tools, libraries, and settings. It's like a recipe for creating a container, ensuring that your application has all the necessary ingredients to run smoothly. These images are built using a Dockerfile, which is a text document that contains all the instructions for assembling the image. We will explore the structure of a Dockerfile and its role in automating the image creation process, ensuring consistency and reproducibility across different environments. Docker images encapsulate your application's environment. Now let's explore Docker containers. A container is a runnable instance of an image. It's a lightweight, standalone, executable package of software that includes everything needed to run an application: code, runtime, system tools, system libraries, and settings. Containers isolate applications from one another and from the underlying infrastructure, providing a consistent environment regardless of where they are deployed. Think of containers as isolated apartments in a building, where each apartment container houses a different application and they don't interfere with each other. This isolation ensures that your applications run reliably and securely, without conflicts or dependencies on the host system. So, what's the difference between images and containers? An image is like a class, and a container is an instance of that class. You can create multiple containers from a single image, each running the same application in its own isolated environment. Images are the blueprints, while containers are the actual running applications. The relationship is that of a parent and child. The image is the parent, and the container is the child. Understanding this distinction is crucial for effectively using Docker. This allows you to easily scale your application by running multiple containers from the same image. Now let's dive deeper into how images and containers work together. Now that we've grasped the fundamental differences, let's delve into practical applications. Consider asynchronous processing using Docker containers. This approach enhances application responsiveness and scalability. Imagine a scenario where multiple microservices need to communicate without blocking each other. Message queues like RabbitMQ or Kafka, orchestrated within Docker containers, enable this decoupling. Each microservice operates in its own container, communicating asynchronously through the message queue. This allows services to scale independently and handle varying workloads efficiently, enhancing overall system resilience. Another critical aspect is leveraging caching layers within Docker. Think of it as a high-speed data storage layer. Implementing caching with solutions like Redis or Memcached in Docker containers significantly improves performance. Now that we've discussed caching, let's shift our focus to infrastructure and observability, crucial for maintaining healthy Docker environments. Think of Envoy proxy, a high-performance proxy, as a gatekeeper for your containerized applications. It intelligently routes traffic, handles load balancing, and enforces security policies, ensuring your services remain responsive and secure. We can configure Envoy as a sidecar proxy alongside our application containers, intercepting all incoming and outgoing traffic, providing centralized control. This is particularly useful in microservices architectures, as it decouples routing logic from individual applications. Envoy provides rich observability features, emitting detailed metrics about traffic flow, latency, and error rates. These metrics can be collected by Prometheus, a powerful monitoring system, giving you real-time insights into the health and performance of your Dockerized applications. With Prometheus, we can define alerts based on specific thresholds, notifying us immediately when issues arise. For example, we can set up an alert to trigger when the average latency of a service exceeds a certain value, indicating a potential performance bottleneck. Visualizing these metrics with Grafana provides a comprehensive overview of our Docker environment's health. Another critical aspect of infrastructure within a Docker environment is implementing circuit breaker patterns. Imagine a scenario where one of your services starts experiencing failures. Without a circuit breaker, these failures can cascade, overwhelming downstream services and causing a system-wide outage. A circuit breaker acts as a safety switch, automatically opening when a service becomes unhealthy, preventing further requests from reaching it. This allows the failing service to recover without impacting the rest of the system. When the service recovers, the circuit breaker will automatically close, resuming normal traffic flow. Implementing circuit breakers within your Docker environment can be achieved through various libraries and frameworks, such as Hystrix or Resilience4j. These tools provide pre-built circuit breaker implementations that can be easily integrated into your applications. By combining Envoy proxy for traffic management, Prometheus for monitoring, and circuit breakers for fault tolerance, you can build resilient and observable Dockerized applications. These patterns are essential for ensuring the stability and scalability of your services, especially in complex microservices architectures. Now let's dive into some practical tips for optimizing your Docker images. Implementing circuit breakers provides resilience. Let's discuss infrastructure and observability within Docker, focusing on Envoy proxy for enhanced control and visibility. Envoy acts as a service mesh proxy, managing traffic between Docker containers. Its dynamic configuration and rich observability features are invaluable in distributed environments. I'll explain how Envoy works. I want to emphasize the importance of monitoring. Prometheus is a powerful tool for collecting metrics from your Docker containers and Envoy proxies. Let's see how they work together. By integrating Prometheus, you can gain real-time insights into the performance of your Dockerized applications. This data-driven approach enables proactive issue resolution and optimization. More details incoming. Now that we have a clearer understanding of monitoring, let's discuss scaling strategies for our Dockerized applications. Scaling ensures our applications can handle increased traffic and maintain performance. We'll explore horizontal scaling, which involves adding more container instances to distribute the load. This approach enhances resilience and availability, allowing us to seamlessly handle spikes in demand. Think of it as adding more workers to a team to tackle a larger workload, ensuring that no single point of failure can bring down the entire operation. Implementing load balancing becomes essential to distribute requests evenly across these instances. Another crucial aspect of scaling is managing stateful applications. Unlike stateless applications, stateful ones require persistent data storage. We can use volumes to persist data across container restarts and updates, ensuring that data is not lost when a container is removed or replaced. For more robust solutions, consider using managed databases like PostgreSQL or cloud storage services like AWS S3. These services provide scalability, reliability, and data durability. Imagine a database as the memory of your application. It needs to be preserved and accessed consistently. Proper data management is key to successfully scaling stateful applications in a Docker environment. Before we wrap up, let's look at some advanced tips for optimizing your Docker workflows. One important aspect is multi-stage builds. Multi-stage builds allow us to create smaller and more efficient images by separating the build environment from the runtime environment. This reduces the image size and improves security. Another tip is to use a .dockerignore file to exclude unnecessary files from the build context, further reducing the image size and build time. These optimizations can significantly enhance the performance and security of your Dockerized applications. It's like tidying up your workspace to ensure everything runs smoothly and efficiently. In summary, we've explored the fundamentals of Docker, including containers, images, networking, and orchestration. We've also touched on monitoring, scaling strategies, and advanced optimization techniques. Understanding these concepts is crucial for building and deploying modern applications. Remember that Docker is a powerful tool, but it's essential to use it responsibly and securely. By applying the principles we've discussed, you can leverage Docker to streamline your development workflows, improve application portability, and enhance overall system reliability. Continue experimenting and exploring the vast ecosystem of Docker tools and resources to unlock its full potential. Thank you.
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.